In today's lesson over conic sections, we're going to talk about hyperbolas. And the definition of a hyperbola is the set of all points so that the difference of the distances between two fixed points, or foci, is constant. So you may recall that with an ellipse, that was the set of all points so that the sum of the distances between two fixed points is constant. Well, in a hyperbola, it's the difference. So let's get into labeling the parts of a hyperbola, because there are many terms, new vocabulary words that you've got to remember, but you may recall some of the vocabulary terms from previous lessons. So in a hyperbola, obviously we've got these, you can have two different forms of hyperbola. You can have like these parabola looking things that go out in opposite directions. They can either go sideways like this, they can go up and down like this, and that's what we're going to be working with today. So in labeling this parts of a hyperbola, let's first label the center point, okay? This center point right here is, again, HK. That's the same as with an ellipse, that's the same as with a circle. So the center point is HK. Now we have these two black dots here that I've got, and they are equidistant from that center point. And let's see, I'll label them green. That right there is a vertex. And your vertex, the distance from the center point to that vertex is A. Okay, so we can label this as an ordered pair, A, 0. And the same thing goes with the other side of that center, that's also a vertex. It's also A units from the center, and we can label this as an ordered pair, negative A, 0, right? We're going to the left A units. So with an ellipse, your focus was on the inside of your ellipse. In a hyperbola, your focus is further out, okay, from your vertex. So it's in an ellipse, remember it looked like this, and these were your vertices on that major axis, and your foci were inside your ellipse. Well, with a hyperbola, it actually goes center, and then you hit your vertices, and then you'll hit your focus. So your focus is further out on that main axis, and that is, just like with an ellipse, C units from the center point. So we'll label this as an ordered pair, C, 0. And this over here is also a focus. It's also C units from that center point. And so we'll label this as an ordered pair, negative C, 0. Okay, and I'm going to erase this ellipse down here. And all of these lie on what is known as, like, this entire axis right here, this whole thing right here, that is called, and I'm going to erase that line, that's called the transverse axis. The transverse axis. I'm going to write that in all caps. That is the transverse axis. So this is your brand new vocabulary word. That's like your main axis. It's almost like you can think about your major axis. That's your transverse axis. That's the axis that has your vertices on it. That's the axis that has your foci on it, and it's called the transverse axis. So if those points, those black dots on that transverse axis are your vertices, then these black dots on this other axis are your covertices. So this is a covertex. And as with, we're using the same variables when I talk about like the distance from the center. So the distance from the center point to that covertex is B units. And I have a covertex down here as well that is also B units from that center point. So we can label these as an ordered pair. 0, B, I'm going up B units, and this down here would be 0, negative B, I'm going down B units. And those points, those covertices, lie on what is called the conjugate axis. the conjugate axis. Okay, whoops, I don't know why I did that. The conjugate axis. So when we talk about a hyperbola, I've got these two parabola-looking things going out in opposite directions, okay? They have a vertex right here, okay? Each of those has a vertex, and they will approach an asymptote on both sides, okay? Which means they'll um, infinitely get closer and closer and closer to this line, and they will never, never touch it, right? They'll just get infinitely closer to that line. That is an asymptote. So here we have an asymptote, and here we have an asymptote over here as well. Okay, so we have this asymptote that crosses through that center point. So there's a lot going on. There's a lot to label, and everything on the hyperbola on the right, which is just a vertical, right? Your transverse axis is vertical, conjugate axis is horizontal. Your foci and your vertices are still on that transverse axis, but your parabolas, or your openings are going up and down, right? So let's see. I don't want to call those parabolas necessarily. So let's just get into, you had like your major axis with the ellipses and your minor axis. Well, the big terms here for hyperbola are your transverse axis. So your transverse axis, the length of it is going to be 2a. It connects the points through this. It connects the vertices through the center. That's the length of your transverse axis. So, really the length of your transverse axis, I probably shouldn't even label it out here. I probably should label it like right here, because your transverse axis only goes from vertex to vertex, okay? And the length of that transverse axis is 2a. It's right here, this point to that point. Your conjugate axis runs from covertex to covertex, and the length of that conjugate axis, so from endpoint to endpoint, is 2b. It is perpendicular to the transverse axis, and it connects the covertices. So these are important things to have in your notes. Okay, so those are parts of a hyperbola. Now let's get into when we're talking about equations, right? Because we've got to be able to match an equation with a graph. That's a big thing with conic sections. And obviously your two options were you could have, and I'm going to zoom out so you can really see, and I'm going to change this to red. When your transverse axis is horizontal, so what I like to write, when my transverse axis is horizontal, I usually do something like this. I'll say, okay, it looks like that, and then my openings go out sideways like that, okay? When my transverse axis is vertical, there's your transverse axis is vertical, and your openings are going to go opposite directions like that. And I'll usually draw a little picture when I'm writing equations just to help me when I am, writing the equations. So you might look at these two equations. Just go ahead and take a little peek. They look very similar to the equation for an ellipse. What differences do you notice? Huge difference. We have a minus sign, okay? Which ultimately means one of these is negative. And you have to be really careful, because I could write this equation on the left, I could write it, or this equation, let's say on the right, I could write it like this: negative x minus h squared over b squared plus y minus k squared over a squared. And, some students look at that and go, oh, it's plus, it's an ellipse. Well, really, only one of the fractions, one of the rational expressions, has to be a negative. So just be careful how it's written, okay? It's not a positive term plus a positive. It's a negative plus a positive, right? So Just keep in mind that they can be written slightly different. When your transverse axis is horizontal, your large term, or I'm sorry, yes, your large term is underneath the positive fraction, okay? So when your transverse axis is horizontal, you'll have a negative in front of y. So that's one of the things that I'm noticing, right? You'll have a negative in front of y, and when your transverse axis is vertical, you're going to have a negative in front of the x. Sorry, I kind of switched between, I kind of wanted to talk about A, but actually I just want to talk about where the negative is, right? So when I'm noticing that this is a hyperbolic equation, I've got a negative in there somewhere. And when the negative is in front of the y, transverse axis is horizontal. When the negative is in front of the x, the transverse axis is vertical. Now let's talk about where the A values are. The A value, right, which is the distance from the center point to a vertex, that's what A is. A is always under the positive fraction. It's always under the positive fraction. Okay, so it doesn't necessarily have to be bigger. Okay, and that's what I think I might have said that incorrectly earlier. It does not have, A does not have to be bigger in this situation. When we're talking about hyperbolas, the A value is always under the positive fraction. With an ellipse, your A value is always the bigger number. It doesn't necessarily have to be that way when we're talking about hyperbolas. Now let's talk about the asymptotes. The asymptote here, this is really your slope when your center point is at 0, 0. Your slope is positive or negative, right? Because we have two asymptotes, B over A, which I'm going to show you kind of a quick way to do this. And then your asymptotes, when your transverse axis is vertical, is positive or negative A over B. So I tend to, there's usually a lot of information, especially on day one when we're talking about hyperbolas. I don't focus a whole lot on the asymptotes. The last thing that I want to talk about on this page is how A, B, and C are related. A, B, and C are related using this equation. C squared equals A squared plus B squared. So just keep that in mind, right? When we're writing hyperbolic equations, we need an A value and a B value, and we're not always given that information. So this little handy dandy equation will help us find those values. Okay, and in your notes, I give options to label parts of a hyperbola like this. There's lots of options here. Okay, let's move on to graphing hyperbolas. Your steps to graph a hyperbola are, as with an ellipse, you need to choose the appropriate graph. But in this case, you're deciding, is your transverse axis vertical or horizontal? And you can draw a little picture. Which way does it open? Let's do that on problem number 1. Okay? So, when I'm looking at this, I can tell that it's going to be a hyperbola because I have a positive in front of one fraction and a minus in front of the other, or a negative in front of the other. And that negative is in front of the y value. What does that tell me? When the negative is in front of the y, it's going to open sideways. So I'm going to draw a little picture. Transverse axis is horizontal. My hyperbola is going to open sideways. Okay, so transverse is horizontal. These are just little notes that help me remember. Now, where is my center point? This is the next thing we're going to do. We're going to graph the center point, HK, and identify the values of A, B, and C using the equation C squared equals A squared plus B squared. So let's graph our center point. Our center point here, there aren't any translations. It's just 0, 0. So we're going to graph that center point. And now let's determine the values of A, B, and C. Remember that A is the distance from the center point to each vertex. It's also the value that's under the positive fraction. This right here is a squared. So a squared equals 64, which means a is 8. So let's go ahead and go out 1, 2, 3, 4, 5, 6, 7, 8 units from the center on that horizontal transverse axis. And now let's find the value of b, which these are where your these are going to help us determine where our co-vertices are. So this right here is b squared, which is 36. If b squared is 36, then b equals 6, which means from that center point, I'm going to go up 1, 2, 3, 4, 5, 6 units, and down 1, 2, 3, 4, 5, 6 units. Okay, and we're going to look at finding c after we do our graphing. Because I'm going to show you, we have to graph our asymptotes to then decide where we're going to, I've got a little mess up right here. We're going to graph our asymptotes to decide, exactly how to draw our hyperbola. So what you're going to do is if you draw a rectangular box where it's passing through each vertex and each co-vertex, and I do this in a really light color, this helps us determine where our asymptotes are. If I draw a line going through that center point, through the corners of this rectangle, that is the asymptote. Oops, the positive and the negative asymptote. You can find it using the equation. I just don't typically, students typically have a lot of problems with this, especially on day one. So this is a really good method to find where your asymptotes are in this equation. If you're really wanting to find the equation for the asymptote, it's going to be y equals positive or negative b over a. That would be y equals positive or negative 6 over 8, which simplifies to 3 over 4. Okay, that's the slope of that asymptote. Okay, you can obviously find the equation of it using point slope form, right? So anyways, so let's move on to graphing the rest of this hyperbola. So I know that it's going to open sideways, and there's my vertex, which means it's going to open like that and approach that asymptote, as well as this asymptote, that asymptote, as well as this asymptote. And now let's look at finding the value of c, right? And this is just helpful practice when finding the value of c. So c squared, I know that the values are related, equals a squared plus b squared. So I can find the value of c by plugging in a squared, 8 squared, which is 64, b squared, which is 36. When I add 64 plus 36, I get 100. And then to undo this equation, I'm going to take the square root of it, and I get 10. Which means the foci are 10 units away from that center point. So here's a focus, and here's a focus. Okay? So let's move on to example number 2. And in example number 2, let's see what we have here. I see that it's definitely going to be a hyperbola because I have a positive in front of one term, one fraction, and a minus in front of the other, a negative in front of the other. So I know it's a hyperbola. And since that negative is in front of the x term, I know that it's going to open up and down. So my little picture that I draw is a vertical transverse axis, and it's going to open like that. Okay? So now let's determine where our center point is. Our center point for this hyperbola is, I'm looking at my x term first, and remember, it's just like with a circle, just like with an ellipse. I'm taking like the opposite of the number that's in there because it affects it by x minus h. So my x term would be -5. My y would be +2. Let's go ahead and graph that. Left 5, up to. There's my center point. I know my, and I'm using kind of like different colors here for each one. So I know my A value is always under the positive term, okay? It's always under the positive fraction, which means this right here is A squared. If A squared is 9, the value of A is 3. A is the distance from the center point to the vertex. Since my transverse axis is vertical in this problem, I'm going to go up 3 units from that center point. There's one vertex. Down 3 units from that center point, and there's the other vertex. So now let's find where our co-vertices are. Our co-vertices are found using our B term. If B squared equals 16, then B equals 4. B is the distance from the center point to the co-vertex. That co-vertex lies on the conjugate axis, which is horizontal in this case. So I'm going to go 1, 2, 3, 4 units to the right, 1, 2, 3, 4 units to the left. Now let's draw our asymptotes. We're going to connect our co-vertices and vertices using a rectangle. So it's going to pass through each vertex, each co-vertex, and that will tell us it will help us with where our asymptote is. So I'm not using an equation. That's not in this particular lesson. I'm not focused on that. We're just graphing, and we're going to draw a dotted line through that corner of that box that we just drew and the center point for this hyperbola. So it's not like totally perfect, but it's good enough. So those are my asymptotes here. And now we're going to graph our hyperbola. And the hyperbola is going to open up or down. So there's my vertex. It's going to approach that asymptote and that asymptote. It's going to go through this bottom vertex and approach that asymptote and this asymptote. And now we're going to practice finding the value of C. And I will tell you though that if you do need to find like the slope of each asymptote, in this case, it's going to be positive or negative A over B, which in this case would be positive or negative 3 over 4. So that's not necessarily the equation for the asymptote, but that is the slope of that asymptote. So now let's find the value of C. The relationship is A squared plus B squared equals C squared. If A is 3, then A squared is 9. If B is 4, then B squared is 16. 9 plus 16 is 25, and the square root of 25 is 5. So the value of C is 5. And remember, those are our foci, which you don't necessarily, in this case, I'm not saying that you have to graph your foci, but if you do, they're 5 on the 5 units from the center on the transverse axis. Sorry. So from that center point, I'm going to go up 1, 2, 3, 4. There's one focus. Then I'm going to go down 1, 2, 3, 4, 5. There's the other focus. So let's get into this last example for graphing a hyperbola. I know these notes are long, but there's just a lot with, graphing and all that stuff with hyperbolas. So, okay, so in a hyperbolic equation, it's just like with an ellipse, it's set equal to 1. If it's not set equal to 1, we need to set it equal to 1. How do I do that? I need to divide this term by 64, which means every term on the left I need to divide by 64. And then we can rewrite it. 16 divided by 64 is 1/4. That's what it simplifies to. So I can rewrite this as y minus 3 squared over 4 minus 4 divided by 64. That simplifies to 1/16. So I can write x plus 1 over 16 equals 1. And now I can see that I have the equation of a hyperbola because I have a positive in front of one fraction and a minus in front of the other, or a negative. That negative is in front of the x term. When it's in front of the x term, it's going to open up and down. which means I have a vertical transverse axis and it opens like this. Okay, so where's my center point? Let's graph that. The center point is going to be at, the x value is going to be -1, right here, -1. The y value is going to be +3. So at -1, +3, there's my center point. Now let's find our a and b values. The a value is the distance from the center point to the vertex on the transverse axis. It's always under the positive fraction. So a squared is going to equal 4, which means a equals 2. From that center point, going up 2 units and down 2 units would show me where my vertices are on that transverse axis. Let's find our b values. B squared equals 16, which means b equals 4. B is the distance from the center point to the co-vertex on either side of the center. So I'm going to go out 1, 2, 3, 4 units, 1, 2, 3, 4 units on either side of that center. And then I'm going to draw my rectangular box connecting all the vertices and co-vertices. This is going to help me draw the asymptotes. The asymptotes are going to go through that center point, and they're going to enter or cross through the corners of the box we just drew. This is like a little trick, if you will. Okay, so remember in this case, the asymptote would be found, the slope of it would be positive or negative a over b, and this would just be the slope, which would be positive or negative 2 over 4, which is positive or negative 1/2. Okay, and that's the slope of that, of each asymptote. Okay, so you could draw it exact from that center point. If you need to find the equation, you can use point slope form. So let's now move to, I'm going to pick a different color here, finding the value of c. Oh, actually, let's graph the hyperbola. So you know it's going to open up or down. It's going to pass through that vertex and approach the asymptote on both sides. So there's how you would draw it. And now let's find our c value. And that c value is the distance from the center point to the focus, to each focus on the transverse axis. So it's related using the equation c squared equals a squared plus b squared, which is c squared equals 4 plus 16. 4 plus 16 is 20. And the square root of 20 simplifies to, if I want to simplify this non-perfect square root, that's square root of 4 times the square root of 5. The square root of 4 is 2, so it simplifies to 2 root 5, or 2 square roots of 5. Which, if you want like to graph it on your coordinate plane, you could plug it into your calculator. It's approximately 4.47, right? That's the distance. So I could go out, down 1, 2, 3, 4. It's about right there and a little more. Up 2, 3, 4. It's about there and a little more. Okay, so those are your foci, your focuses. So now let's get into writing equations of hyperbolas. Your steps to write hyperbolic equations. Well, you need to choose the appropriate form of the equation. Which axis is longer, right? We keep talking about that. Which axis is longer? Which way does it open? Okay. Where is the positive? Where is the negative? Is it in front of the x, or is it in front of the y? Then you need to identify the values of a, b, and c. Really, you only need a and b, and then we're going to write the equation. So on example number 4, it says, write the equation of the hyperbola in standard form with a center at 0, 0. The hyperbola has a horizontal transverse axis. What does that tell you? If there's a horizontal transverse axis, this tells me that y is negative, okay, or negative y, all right? And so let me write it that way so you don't think y minus. It's negative y, okay? The length of the conjugate axis is 8, and the distance between the vertices is 16. Okay, so I know that the center is 0, 0. I know that the horizontal axis is the transverse axis, which means there's negative y. So this is what I can write at first. X squared over something minus y squared over something equals 1. And I can write it like that because I know that I'm not translating the center point left or right. It's staying at the origin. And I know the x term is positive, the y term is negative. Okay, so let's move on to the next thing. Now I need to find my a and b values. I know that the length of the conjugate axis is 8. Well, the length of the conjugate axis is 2 times b, right? It's the b value is the distance from the center point to one covertex, and from one covertex to the other covertex, that would be 2b. So to find the value of b, I just divide by 2, and I get 4. If b is 4, then b squared is going to be 16. Okay, so, and that's going to be underneath a. Remember, a is always under the positive fraction. A is always under the positive fraction, which means this right here would be under the negative. So let's move on to A. The distance between the vertices is 16. Okay, well that's the length of the transverse axis. So 2A equals 16, which means the value of A is 8. A is always under the positive fraction, which means 8 squared is here. So if I'm going to write this equation, it's going to look like this. X squared over 64 minus y squared over 16 equals 1. That's how you write that equation. Let's move on to number 5. These notes are long. Sorry about that. There's a lot of information. Okay. Number 5 says, write the equation of the hyperbola in standard form with the center at 3, 4. I'm going to write that down. The center, our HK, is at 3, 4. The hyperbola has a vertical transverse axis. That means it's going to look like this. And that vertical transverse axis means there's the x is what's negative, right? There's negative x. The foci are 10 units from the center. That's the value of 10 of C, right? The focus is the distance from the center point to the focus. If it's 10 units from the center, then C equals 10. The length of the transverse axis is 6. Okay, so let's do like the top part. I know that x is what is negative. So what I'm going to do is I'm going to write my y term, y minus 4 squared over something. See how I did that? Y minus the y value of the center squared minus x. Now I'm going to use the x term, minus 3 squared equals 1. So I've got my translations of the center point, right? I'm going right 3 up 4, and that's how I would write it. So now let's find our A and B values. I know the length of the transverse axis is 6. That means the transverse axis has a length of 2 times A, and I know that length is 6, which means the value of A is 3. A is always under the positive fraction, which is right here. So 3 squared. How do I find the value of B? I'm not given B, but I do have the value of C, and I do know the values are related using the equation C squared equals A squared plus B squared, which means C squared is 100, A squared is 9, there's B squared. B squared, if I subtract 9 from 100, I get 91. I don't really even need the value of b. I need the value of b squared, right? The value of b squared is 91. So the value of b, if you do want to write it, is the square root of 91. So let's rewrite this equation. Y minus 4 squared over 9 minus x minus 3, oh goodness, x minus 3, oh no, squared over 91 equals 1. And that is the equation, well, it's not really, there's the equation of this hyperbola. So let's move on to our constant difference. And this is the last thing that we'll do today. We only have one more problem to do, but it's finding the constant difference of a hyperbola. And I'm going to expect that you, watch the notes over the ellipse because we did that first. And the constant sum tells us that when I take a point on an ellipse, right, and I add the distance from the focus to that point with the other focus, the distance to the other focus to that point, when I add those up, I get the constant sum. Well, in this case, what I get is the constant difference. So from this focus to that point, we'll call that D1. And this focus to that point, we'll call that D2. When I subtract those, I get the constant difference. And we're actually going to take the absolute value of it so that it's always positive. So in example number 6, it says, find the constant difference of the hyperbola with foci f sub 1 at negative 5, 0, and f sub 2 at 5, 0, and a point on the hyperbola at 2, 4. So the first thing I'm going to do is find the distance of from this point to this focus. Okay, and I'm going to label this, I'm going to write negative 5, 0, and 2, 4. And I'm going to find the distance of this. And I'm going to label this x1, y1, and x2, y2. And I'm just going to plug those into our formula, our distance formula. So the distance is the square root of, I'm going to subtract those x values. So 2 minus negative 5 is the same thing as 2 plus 5 squared. I'm going to add that to, I'm going to subtract the y values, 4 minus 0, and then I'm going to square that. And then I'm just going to simplify this all the way down. 2 plus 5 is 7. 7 squared is 49. 4 minus 0 is 4. 4 squared is 16. 49 plus 16 is 65. And I'm going to take the square root of 65. I can't simplify it. Let's move on to our other point. I'm going to take this point right here. And I'm going to find the distance from that point to, or that focus to this point right here. And I'm going to find that distance using that distance formula again. So I'm going to label this x1, y1, and x2, y2. And you don't have to do that. I'm expecting you, just because I've done a review over distance formula, and we did this with the ellipse, so I'm kind of working fairly quickly through this. So now I'm going to subtract the x's, which is 2 minus 5. I'll square that, add that to 4 minus 0, and then we're going to square that. So I'm going to simplify this. 2 minus 5 is negative 3. Negative 3 squared is 9. Plus 4 minus 0 is 4. 4 squared is 16. 9 plus 16 is 25. And the square root of 25, since it is a perfect square, is 5. So what I'm going to do is the constant difference for this hyperbola is going to be 5 minus the square root of 65. And I can take the absolute value of that. Okay, there's my constant difference. And that concludes your notes over hyperbolas. I know these were long notes, but I hope they were helpful.